Get it to go. Hello, Reese and Riley. Watching this video. This is 2-9, proving lines parallel. Here we go. All right, let's hold on real quick before we move on. Let's review. Okay, 2 lines parallel. Help me out here. 1, 2, 3, 4. You don't have to write this down, but I'm gonna. So you just help fill these out with me, okay? So 1, 2, 3, 4, 5, 6, 7, 8. We have corresponding angles. Let's just review what these are. Okay, corresponding, we have alternate interior, we have alternate exterior, and we have consecutive interior. You don't have to write this down, but I'm going to ask you which pairs are which. Okay, then in addition to that, we have linear pair. We have linear pair, and we have vertical angles. You don't have to write this down. I'm gonna, and we're gonna list these pairs. Okay, some of them. Corresponding means they're in the same corner, right? So give me one set of corresponding angles. 1 and 5, right? 1 and 5 work. They're in the same corner, right there and right there. Okay, what else?
2 and 6.
2 and 6. What else?
3 and 7.
3 and 7. 4 and 8.
Yep.
Okay, those are my pairs. There are how many sets of corresponding? 4 sets. Okay, alternate interior. Which ones are alternate interior?
3 and 6 and 4 and 5.
3 and 6 and 4 and 5. So how many sets of those are there?
2.
Only 2. How many sets of alternate exterior are there?
2, 7, 1, 8.
2 and 7 and 1 and 8, right? 2 and 7, 1 and 8. Okay, but there's only 2 sets of those, right? Consecutive interior means on the same side but inside, right? What are those?
4 and 6.
4 and 6, yep. And?
3 and 5.
And 3 and 5. And there are 2 sets of those, right? Okay, linear pairs. How many sets of linear pairs are there? How many sets of linear pairs are there? What? 8. How'd you get 8? You're right. 1 and 2, 2 and 4, 3 and 4, 1 and 3. That's 4 of them, right? Those are all on straight lines together, right? 5 and 6, 6 and 8, 7 and 8, 5 and 7. Those are all linear pairs. That is 8 total sets. Holy crap, that's a lot. I'm not going to list them out. I'm just going to say there's 8 sets of linear pairs, all right? Vertical angles. How many sets of vertical ones are there? Which ones are vertical, by the way? Give me a 2 and 3, 1 and 4, right? 6 and 7, 5 and 8. So there is
1, 2, 3, 4, 5.
4 total. 4 total vertical angle pairs, right? Okay, so these are all the ones that we have going together, yeah? All right, here's the deal. Are you ready for how this is different today than what we've done before? Okay, this is very similar to what we've done before. But here's the deal. Ready? Before, they would tell us, they would give to us that these 2 lines were parallel. And then they'd say, like, angle 2 is 120 degrees and find angle 7. Well, angle 7 is also 120 degrees, right? Okay, because they're alternate exterior angles. Now what they're doing is they are saying, okay, we don't know for sure that these 2 lines are parallel. We don't know for sure, but I have measured out and I have found that angle 3 is, let's say, 100 degrees, and angle 6 is also 100 degrees. If those 2 are both 100 degrees, are those 2 lines going to be parallel to each other?
Yes.
Why? 3 and 6 are what? They're congruent, but they are alternate interior, and alternate interior have to match. So it's like going backwards the other direction. We're still doing the alternate interior, alternate exterior, that type of stuff. But now we don't know whether the lines are parallel, and we're having to figure that out based on the information it gives to us. Does that make sense? Okay? So this guy is the converse of the corresponding angles. Okay? Converse means the reverse. Okay, write that really big off to the side. To do the converse means to do the reverse, which is like the opposite, right? Converse is reverse, okay? Corresponding angles. I'm going to go over here and I'm going to show you the diagram. We don't know for sure that A and B are parallel. We don't know that. But they're saying that angle 1 is the same measure as angle 3. And if that is true, angle 1 and angle 3 are corresponding angles. If 1 and 3 are the same, do those 2 lines have to be parallel? Yep. Yes, they do, right? So it's saying the opposite thing, all right? So now we can conclude that those 2 lines are parallel, yeah? All right, I'm going to go down here. Cross out example 1 because we're not going to do it. Let's go down here and let's talk about these 3 real quick. And then we'll go back and do the parallel postulate and the perpendicular postulate. Okay, so let's do these three. This one's alternate interior exterior angles converse, consecutive interior converse, and alternate interior converse. Okay, we're going to write these down, but don't make a new line for them. Okay, we're going to write these down. Alternate exterior. We don't know whether P and Q are parallel, but they're saying 1 and 3 are the same measure. So do P and Q have to be parallel?
Yes.
Yes, because of the alternate exterior angles converse, right? Okay, next, we don't know that P and Q are parallel, but 4 and 5, they're saying add up to be 180 degrees. Those are consecutive interior angles, and if that is true, then do P and Q have to be parallel? Yes, they do. Down here, we don't know if P and Q are parallel, but if 8 and 6 are the same, does P and Q have to be parallel? Yes, because those are alternate interior angles. So it's saying the opposite. We don't know that they're parallel now, but if we know they're the same measure, they have to be parallel, right? We're proving that they're parallel, okay? So doing the opposite thing. All right, so what we're going to do is on your green sheet, you guys have these listed already at the top of the back side of your green sheet. Okay, so we are going to cheat. Woo! We're going to cheat, and we're not going to write down these things again. Okay? This stuff is true. Whoa. Going back. This stuff is true. These corresponding angles postulate, like, let me do my arrow. These guys are true if the lines are parallel, if already parallel. But if we're trying to prove they're parallel, if proving lines are parallel, we're going to use the converse. Okay, and we're going to list all the converses off to the side. Okay, the converse is the reverse. It's the opposite. So rather than the corresponding angles postulate, we're going to do the converse. And that is postulate. What's that number? Postulate what? It's the first one. On your notes, I'll let you get that written in. 220, postulate 220. Okay. All right, alternate interior angles theorem. If I want to do his converse, what's the converse of that one? Theorem what? Interior. They might not go in order. Sorry. Interior is the next one. 222. Okay. What's the converse of consecutive interior? Theorem 221. Okay. They're not going in order, but that's fine. We'll just list them the way that they're supposed to go. And then alternate exterior. The converse of him is it 223? 220. Theorem 220. Okay, so those are the converses. Like, we don't know that the lines are parallel, but if they give me these angle measures, we can say that they're parallel, right? So it's doing the opposite of those. Okay, so the first one is a postulate.
13.
What?
It's postulate 213.
Oh, it's postulate 213? Okay.
Yeah.
Carter?
Hey.
213. Postulate 213. There we go. Okay, postulate 213. So list those off to the side of your green sheet where those guys go. Okay. And then we have all the postulates and theorems right now. And we cheated because we're just doing the converse. I mean, not really, because I didn't want to have to write it down again because it's saying the same thing. Okay. So we're just going to do the converse off to the side. Good? Happy with that? Did you get them all written down? Okay, now let's talk about the other two that we skipped, right? And then we'll actually do some problems here, all right? Ready? This one is the parallel postulate. We're not going to write this one down, but this is important. Listen to this. It's important yet stupid at the same time. Here you go. You ready for this? This one says, if I have a dot right here and a line right here, there are a bunch of different lines I can draw through this dot, right? Like a bunch of different lines, but only one of those lines will be completely parallel to this one. There's a bunch of lines I can draw through that dot, but only one of those lines will be parallel to the bottom one. Does that make sense?
No.
Okay. No? I mean, it's just silly, right? Like, it's like, that should make sense, right? I can only draw one line
Oh.
that is parallel to the bottom.
So you're not talking about the lines already drawn.
Right, right. I'm just saying, out of all of these lines, only this line is parallel to this one. There's only one line that goes through that point that is parallel to the bottom one. Okay? All right, this next one, we're not going to write down, but you're going to use this one again. So keep this one in mind. Ready? We're going to use this one again. On your homework, you use it, and on your notes, you use it, but we're not going to write it down. Here you go. Here's what this one says. We don't know if P and Q are parallel to each other. We don't know that. But this guy is my transversal, and he is perpendicular to P, but he's also perpendicular to Q. So does that mean P and Q are parallel to each other?
Yeah.
They have to be. All right, I'm going to use an example real quick. Let's say that this line has a slope of, I don't know, 2/3, right? Okay, let's just say that. Then it would have to be slanted, but just bear with me, all right? Let's say that transversal has a slope of 2/3, right? If this one is parallel or perpendicular to that, what is his slope?
-3/2.
-3/2. And if this one is perpendicular, his slope is -3/2. But doesn't that mean these two are parallel if they have the same slope? So I've just kind of like proved it, right? Like these are perpendicular, right? Slopes, but they're the same as each other, so they have to be parallel to each other, right? Okay, so that just kind of proves why that is, right? All right, let's go down and do some problems. Flip over to the back side.
Question.
Yes, ma'am.
For 2.22,
Yes.
so the ones above that were like same angle, so they're parallel. One was adds up to 180, so they're parallel. What would the one for that be? For the third one. Like if you go up.
On my green sheet?
No, go back down to the lesson. On the third one, what would the reasoning be for that?
That they're equal.
The angles are equal?
The angles are equal, so those lines are parallel. So 6 and right here. If 6 and 8 are congruent, then those two lines are parallel. Yeah?
Okay.
Okay. All right. So let's do some examples. Here we go. This guy, we're looking at this diagram over here, and it says, given the following information, is it possible to prove that any of the lines are parallel? If so, state the postulate. So they're telling me that angle 1 is congruent to angle 6. Okay. So angle 1 is here. It's congruent to angle 6. All right. This is my transversal that's going between, right? And we have two lines in question, right? L is this guy. I am trying to prove that L is parallel to N. This M in the middle is just chilling out. We don't even look at him, right? But if they tell me angle 1 is the same as angle 6, what do those have in relationship to each other? They're alternate exterior, okay? So does that mean line L and line N are parallel? If they're alternate exterior and they're the same. Yes. So we will start by writing L is parallel to N. Is it N? Yeah, N. L is parallel to N because of the converse of alternate exterior theorem. The converse of that. You can either say this or you can say theorem. Which one was the alternate exterior? 220?
Yeah.
Is that what you said? So, I don't care which one you put. You don't have to put both of those things down, but there's that, right? You can either put theorem 220 or you can put converse of the alternate exterior angles. Okay? What? You do have to tell me which lines are parallel, yes. So this next one, 2 and 3 are the same. We'll practice on this one now. 2 and 3 are the same. Angle 2 and angle 3. Okay? Now we're not looking at this line. We're only looking at L versus M. If angle 2 and angle 3 are the same, does that mean L and M are parallel? Shh. Yes. Why? Yep. L and M. It's the converse of the alternate interior theorem. And you can either write that or you can write theorem. Is that 222?
Yep.
222. I don't care. You don't have to write both of those down, but just write one of them. Okay? If I write this part down, the converse, this guy, it's a lot more writing, but I don't have to look at my sheet because I already know what it is, right? Versus if you want to save some writing, you can write down what theorem number it is, but you have to look at your sheet then, right? Whatever. Okay. All right. Find the measure of angle MRQ. MRQ is this one right here. Okay, that angle that's labeled 5x plus 7, so that A and B are parallel, okay? We want these two lines to be parallel to each other, okay? They give me another angle, and it is this guy right here. If those two lines are parallel, they're equal to each other, and those are alternate interior, okay? So the postulate or theorem you used is the converse of alternate interior theorem, or that is theorem, is that 222 again? Yep, 222. Either one of those you can put down. Okay, now we have to solve for it. Okay? So, how do I solve that?
5x plus 7 plus
5x plus 7
Equals 7.
equals 7x minus 21. There should be equal to each other. Yeah?
I'd say so.
I'm going to minus the 5x, and I'm going to add the 21 at the same time. So, gone, gone. That's 28 equals 2x, yeah? X equals 14. But that's not the answer. They want the measure of that angle. They want the measure of this angle right here.
Plug it in.
So plug it in.
Plug it
14. 5 times 14 plus 7.
17.
Did you do that in your head?
Yeah.
Hey, good for you. Equals 77. 77 degrees.
Did you?
Was I not
Easy.
supposed to?
I didn't.
How'd you do it? What'd you do?
I use the qual.
5 times 4 plus 50.
Yeah. Is 70 plus 7. Yeah. Hey, that's what I did. Yeah?
Woo!
Woo! Right?
Alright.
Yeah? Okay. Moving on. Okay, last one. All right. In this paragraph, they explain some things to you. Can you see this little ladder on your picture? It might be a little dark. Okay. All right. So I have this ladder, and these two lines right here are called rails. Okay. Those are my railings. Those are my rails. Okay. And these guys are called
Yeah. The rungs.
the rungs. R-U-N-G-S. Okay. So we have rails and we have rungs. Okay. Now, you've never heard that?
I haven't.
Rails and rungs? No? Okay.
No.
They're the
I've heard of rungs.
steps, right? Like the step. Yeah, okay.
No, they're rungs.
Anyway, whatever. Okay, they're rails and rungs.
Never heard of
Now,
these
do you
lines being
see
called
these
rails.
little lines? Ooh. Do you see these little lines?
Yeah,
Those
what?
little boxes.
On the table.
But they're rungs.
Do you see these little boxes right here?
They're the
Okay.
same.
All right, that means that this bar right here is parallel or perpendicular to this one and perpendicular to this one, right?
Alright.
The same thing for all of them. All of them are perpendicular to this one and perpendicular to this one. So, do we know for a fact that these two are parallel to each other?
Yes.
Why?
Alternate.
Technically, they are kind of alternate interior. Yes, you could put that down. But there was
they
one
are
that we had on the.
perpendicular.
There was one. It was the very bottom one on the front side.
Mm.
It was the
Vertical angles.
perp converse,
Oh.
the perpendicular transversal converse,
Yeah, we're done.
or theorem 223. So yes,
We have a ball meeting today.
they are parallel. Yes, they are parallel because of theorem 223.
Intercom announcement was the
'Kay, good, good?
meeting link.
Okay, you people watching this video, we are doing odds.
Oh, it's always the first Tuesday.
Odds on the homework on both sides.
Yeah.
It should look something like, I don't know where it is. 2-9, right? Nope, nope, nope. Right here. Odds. And the other side is odds. So skills practice and practice 2-9 is odds. Odds, odds, odds. Okay? There you go. Goodbye.
No.